Hey guys, it's me, Mr. Ziegler again. In this video, we're going to be showing you how to find the equations of parallel lines. And in this specific video, we're going to have a couple of these. We're going to be using the point slope method to do so. Okay, and we'll get into what that is here in just a second. But before we get into solving for the equations of lines, I want to make sure you understand the rule. Now, you probably saw this in a previous video. I hope you did. But when we have parallel lines, we have to know that the slopes of those parallel lines are all going to be the same, okay? And that's going to help us solve for the equations of the new lines that we're going to do here in a minute. Just by knowing that rule, you've got a lot of your work already done for you, okay? And if you don't believe me like that, all of these slopes are going to be the same for parallel lines. If you have a couple parallel lines like this, you can compare the rise and the run, okay? So when you compare rise over run, those numbers would be the same. That means they have the same slope, and that is the slope, okay? So the equations that we're going to be looking for look like this. Y equals mx plus b. Now, m represents the slope, b represents the y-intercept of the line, because you got to keep in mind, you can draw as many lines as you want to on this graph, for instance, right here, that are parallel to the ones that you see. And the only difference in the equations then, because all the slopes are the same, is that y-intercept number at the end, okay? And so all we need really to focus on is those two things. We need the slope and we need the y-intercept. And we're going to be solving for the y-intercept given that we already know what the slope is, because again, we're finding a parallel line which is going to have the same slope to whatever they give us, okay? Now we're going to use the point slope form in this video to do this, okay? And the point slope form looks like this, where you have the slope as part of your template. And then you have these two numbers at x1 and y1. They represent the coordinates of a point that you know are on the line, because you have to have those two things at least to find the equation of a line. You have to know the slope, and you have to know at least a point, the coordinates of a point that are on that particular line. And this does it pretty efficiently. So this formula, if you don't know this already offhand, I would just pause the video for a second, take a snapshot of this, write it down, because this is the most efficient way to solve for the equation of the line that we're looking for, okay? So here's an example of a question that you might see, okay, where you're asked to write the equation of a line going through a specific point that's parallel to the given line. So, and then they give you a point and the line. So that line equation, that y equals 4x minus 2, just keep in mind that's the original line, okay? That really, the only reason they give that to us is because we need to know what the slope is, because we know parallel lines have the same slope. So the equation of the line that we're looking for in this case is going to start out kind of the same way. Since the slope is 4 in this one, then the slope of our new line is going to be 4 also. Okay, so but it's important. We are looking for the equation of a new line that's going through this point A32 in this case that they're giving us here. Okay, so it's very important. We're using that. So the only reason we need that line that they give us then is for the slope. Okay, we don't care about that y-intercept value that they give us here, that minus 2 at the end. That has no bearing on what we're doing. Okay, so, and this might be a good strategy to kind of keep yourself clear on what you're trying to do by circling the slope and then crossing out that y-intercept, because you don't want to use that number. Okay, that number is not going to be used at all. Again, the only reason we have this equation is for the slope, okay, because we're going to plug that into our formula, which looks like that. Again, we saw that on the previous slide. And so if we know the slope of our original line is 4, we can plug that into our formula. And then our x1 and y1 numbers are those x and y values from the new point that we have that we can now plug in, and then we can just solve for the equation of the line. So it looks like something like that. We plug in the 4. We know that's the slope of our new line because it's going to be parallel to the original line. And then we have an x value of 3 and a y value of 2 that we can plug into this formula. And now we're going to solve from here. We've got an equation. The first thing we would need to do is distribute that 4 out to the x and to the negative 3. That means you're multiplying 4 times both those numbers. And so when we do that, we get the left side is y minus 2. The right side then would be 4x minus 12, because 4 times negative 3 is negative 12. And now all we have to do is one more step in order to solve for the equation of the line, and that's to get y by itself. We add the 2 to both sides, and now we find the equation is y equals 4x minus 10. And that is the equation that we're looking for that passes through the point 3,2. So stay tuned. In another video, we're going to talk about another way that you can solve for this, but I think this is the most efficient way to do so. So we'll see you in the next video.